The topic is using the rational zero theorem to factor completely. So let's do this example. Factor completely f of x equal x to the fourth minus x cubed minus 2x minus 4. The theorem says if you have a polynomial that's written in that form, if p over q is a rational zero, of course written in the lowest terms, then p has to be a factor of this constant, a 0, and q has to be a factor of an, which is the coefficient of the highest degree term. So what does this tell us? This tells us that p over q, p is a factor, comes from the factors of 4, of 4, the constant, which is minus plus 1, minus plus 2, minus plus 4. And q comes from the coefficient of x4, which is 1. So q either minus or plus 1. Now what are the possible rational zeros? P over q. Of course, they're going to be dividing all that stuff. You get minus plus 1, minus plus 2, minus plus 4. So let's try x equal 1, see if it works. If it's a 0, f of 1 will be 1 to the fourth minus 1 cubed minus 2 times 1 minus 4. Actually, that will be equal to negative 6. So it's not 0, then try negative 1. F of negative 1 would be negative 1 to the fourth minus negative 1 cubed minus 2 times negative 1 minus 4. That would be 1 plus 1 plus 2 is 4. 4 minus 4 is 0. So what does that tell us? That tells us that x minus minus 1, which is x plus 1, is a factor of f of x. Which means if we divide by x plus 1, the remainder will be 0. So let's do synthetic division. So plug in negative 1, our k. The coefficient of x4 and so on will be 1. A coefficient of negative x cubed will be negative 1. Remember, there's no x squared here, so we have to put a 0 for x squared, and then negative 2 for x, and then negative 4. And now we drop 1. 1 times negative 1 is negative 1. We add, we get negative 2. Negative 2 times negative 1 is 2. 0 plus 2 is 2. 2 times negative 1 is negative 2. You add negative 2 and negative 2, you get negative 4. Negative 4 times negative 1 is 4. We get 0, so that's our remainder. And this is how we know we didn't make a mistake. Now, since this is a degree 4, the quotient will be in degree 3, so that would be x cubed minus 2x squared plus 2x minus 4. So far, f of x is equal x plus 1, x cubed minus 2x squared plus 2x minus 4. Now again, we do the same thing, the rational p over q. We still have a negative 4 and 1. So we already tried negative 1 and 1. Now let's try 2. Plug in the 2. All we need to do plug it here because we know we're going to get a 3 here. So let's call this g of x. So g of 2 will be equal 2 cubed minus 2 squared plus 2 times 2 minus 4. You can tell it's 8 minus 8 plus 4 minus 4, which is 0. So what does that tell us? It tells us we can divide by x minus 2. So x minus 2 is a factor. So therefore, x minus 2 is a factor of g of x or f of x, same thing. So we need to divide g of x by x minus 2. So let's use a 0. So what are the coefficients? 1, negative 2, 2, negative 4. Drop 1. 1 times 2 is 2. You add them, you get a 0. 0 times 2 is 0. Add, you get a 2. 2 times 2 is 4. You add, you get a 0. That would be the remainder, which makes sense. So that would be, since this is a cubic, this will be quadratic. So that would be 1 times x squared plus 0 times x plus 2. Which is, we can actually finish it here, which is equal to x plus 1, right? And then x minus 2, right there. And then x squared plus 2, right? 0x is just 0. Now we got one more step and we're almost done. All we need to do is factor this. So x plus 1, x minus 2. All I need, x minus something, x minus something else. So how do we do that? We need to find the 0. Let's use a complete factor theorem. Complete factor theorem, all it says is you can pull the an. In this case, it's just 1, right? These are 1 here. So we don't have to pull anything. So it's just going to be x minus c1, x minus c2. So all we need to do is find the zeros of x squared plus 2. So set it equal to 0. This means x squared is equal to negative 2. X is equal minus or plus. Use square root theorem. Square root formula. Minus 2. This will be minus or plus I square root of 2. So I'm going to plug I square root of 2 here. Minus is plus I square root of 2. And I'm done. I factor it completely. So write f of x equal. And that's it for this problem.